Our final presentation this afternoon is the HFC Evolution to Distributed Access by Juha Kangas who's the DAA Project Manager for TELESTE. Juha joined TELESTE in 1990 and engineered video processing and data transmission products. At the time, traditional broadcasting networks were widespread and the first interactive cable television networks were just being built. Since 1997, Juha has worked in several managerial positions and currently is responsible for product management of distributed data access solutions. His interest lies in comparing different network architectures and finding optimal migration paths to achieve the wished outcome. Juha holds a bachelor's degree in telecommunications from the Turku University of Applied Science in Finland. Thanks, sir.
Okay, thank you also from my side the opportunity to be here to tell you how the HFC networks can develop in the future. So my presentation is touching this distributed access evolution and TELESTE has started to make trials already with the operators to build real distributed access architecture systems, and for me it has been quite interesting journey from cable lab standard through the product development to deploy real systems to operator environment. It has been kind of front row viewpoint to see what comes up when the operators start to deploy these distributed access architectures. We have realized that it's not so hard thing, even someone might think that all things will change, but there is not so radical change from the operational viewpoint. The terminology stays bit almost same. I mean that DOCSIS systems and these kind of things, it just makes possible to build system bit different way, but still traditional coax remains as a last mile access, and the optical transmission is as standard as possible. So it's not so big challenge to go towards to distributed access architectures. Naturally, there always when there is a change in the industry or systems, there needs to be small adaptation to, for example, telemetry things, how to measure and maintain the coaxial network, for example, frequency responses. So something needs to be adapted also in these changes. So I believe you are well known about this, what does the distributed access architecture means, but let's take once more time this. So operators has been running this kind of centralized CMTS systems through the traditional HFC since the DOCSIS was early phase. And this is now going to change more distributed access style networks where we have where we replace pretty much analog HFC fiber to digital transmission to node size. So this enables 10 gigabit access to node level in the network, which naturally makes possible to deliver high data rates to subscribers. So here we just take these downstream, upstream interfaces and place them to node level, and also creates a digital link between the CCAP core, which is still holding the intelligence of the system. In this presentation, we concentrate to this node level functions, what should be there, and how the node will change in this transition. Naturally, this has also evolution step to make more virtualization, so the CPU core can make the more virtualized in longer term. Okay, so why this happens? We have heard that there are hard competition in high-speed broadband data services to subscribers, and how the cable operators can cope with this challenge to offer more and more bit rates to subscribers who is consuming the video services in their laptops or whatever it is, but it's always demand more and more data transmission. So operators start to reach the space limitations and power limitations in their head ends. So how to make more space to utilize higher bit rates? You need to throw something out and replace that with more efficient solutions. How to make fiber utilization better or more efficient, that we are not consuming too much, for example, analog wavelengths. We can replace them to digital transmission, which has much higher capacity, and so on. So there are drivers to go towards the fiber to the home solutions, and this is natural step in that progress. The fiber to the home takes time that it is really in every home. So this is already, this distributed access architecture makes optical transmission much closer to the homes than before. We are not spending here too much time. Let's look inside what runs in HFC plant, what kind of services. So naturally there are these services for subscribers, but in the background there is also the different kind of management systems which are sharing the same HFC platform. And this is just needed that this coaxial network is up and running 24/7 hours all the time without interruption. So you really need to have tools to collect data and then use like data miner systems to then analyze what is the situation there and make a correction if needed. So all these I call the OOP, out of band services, and how these are made in nodes, which in this when the system is converted to distributed access architectures. So in this picture we have kind of traditional HFC solution where we have services coming through the analog optics downstream to the subscriber, and then naturally the DOCSIS upstream back to CMTS. And together with that there are naturally these sharing these downstream and upstream parts for these management features. So if you want to now convert this to work in distributed access, we need to add the remote PHY device module into the node. So what this enables? It enables the 10 gigabit trunk feed to node level, which is then enough capacity to make any high speed data to the subscribers. What other benefits are here is that all the legacy systems can still work because there is no change in the analog overlay functions. Naturally, this wastes a bit more wavelengths in the fiber, so there is a more cost to deploy this, but this might be very interesting when to start to build the distributed architecture solution. Next step is naturally that how to optimize this more efficient and maybe save some operational cost. So operator might start to think about how to get rid of the analog fiber. So in this solution we have taken away return path optics, and well, we still have the same high data capacity to the subscribers, and just compatibility reasons we keep the downstream overlay, RF overlay, there to make possible to run these existing services which is one-way services. But in this solution already RPD needs to support the data communication for telemetry systems and HFC element management systems. So there needs to be some tools inside the RPD and CCAP core to support, make the two-way communication for these systems. So a bit more optimized than previous one because we does not need any more to run this analog optics, upstream optics. And also this might free up the space in the head end that there doesn't need to anymore be any hardware for that purpose. But naturally, the optimum solution is to make pure RPD for this remote node. And now the aim is that all the services, including the subscriber services and management services, are running through the CCAP core system through the RPD to coax network. So now we really said that this RPD solution must support two-way communication for these additional OOP services. Are they defined somewhere or not? Let's look what Cable Labs has defined for those purposes. So Cable Labs specification defines so-called tools, narrow digital forward and narrowband digital return path for that purpose. And what are these features? They actually are the functions that you filter small band where you have your management system carrier and digitize that to digital samples and transmit that through the system. In the other hand, where it is reconstructed similar it was in the original place. So let's take an example that we have here, for example, element management communication channel modulator. So it is sampled, digitized in this point, and using this Ethernet link, we transfer the digital samples to RPD, and in this other end, this system plays out the exact copy of what has been digitized in this starting point. So it's a transparent channel from CCAP core to RPD, and likewise from RPD back to the CCAP core, offering possibility to transfer any of these OOP services management channels. So this specification defines that the sampling frequency band can be as low as 50 kilohertz up to 20 megahertz. So it adapts based on the settings you use, and you can, if you have 1 megahertz modulated carrier, you can only take that part for digitation and send that over the system. So it's flexible tool these are flexible tool to deliver any of these additional services through the system. This is just drafting the spectrum, how they are located, these OOP services in the spectrum. So green ones are like digital TV carriers, blue ones are, for example, DOCSIS 3.0 carriers. There are other colors in here, so we might think that these yellow ones are for example, telemetry communication channels, so that the hidden device can communicate with measuring device which is used in the coaxial plant. Or they can be HFC element management system communication carriers downstream and then the upstream to get the information what is the health of the nodes and amplifiers in the coaxial network. There can be pilots like violet one to use for amplifier amplification adjustments or some leakage carrier which can then be used to detect network leakages. So there are quite many different of these located in different part of the spectrum, which means that this NDF, NDR feature must be agile to adapt to these requirements. When the operator decides to deploy DOCSIS 3.1, there might be challenges, especially in the range where is this extended upstream. That if some communication OOP systems or communication channels has been designed to work there, they must then adapt to move upwards in the frequency spectrum because this is now assigned upstream traffic only. So some systems might need the small adaptation to still used in the system. Well, operator for sure wants that all these subscriber services and legacy management systems must work also in distributed access architecture systems. So let's look what does it mean, how they are defined service by service in specification. So, well, analog TV, we believe it's disappearing. It has also already disappeared in many countries. But let's consider these other services. So DOCSIS is very carefully defined in Cable Labs modular head-end standards. So the video is enabled through the CCAP features. We can deliver FM and DAB bands using the NDF once it is configured to use the wider bandwidth, like 20 megahertz. So then we can deliver a full FM band from head end to coax plant and using this NDF feature. HFC element management requires two-way communication. There we need to utilize the both directions as well. For the telemetry usually it takes it's a two-way communication between the head-end device and the measurement device in the field. Then one-way additional services are pilot tones, which are usually carriers. These must be generated by RPD, but all of these are defined in Cable Lab standards. So that's make sure that there can be multiple vendors designing these products and operator have possibility to choose who are the best vendors to trust deliver the quality to remote files to their network. Regarding the remote PHY device specification, we need to think about how many of these narrowband digital forward and narrowband digital return band we need to deploy the real systems. So this is speculating just that for downstream we need at least 3 of those to deploy FM plus some telemetry system, and also the HFC element management system. So at least 3 of those forward path, narrow band digital forward tools needs to be in remote PHY device, and then likewise in the upstream, those two-way communication requires for telemetry and HFC management. That I end up the amount of, this is the kind of minimum setup you need to have in the remote PHY to support all necessary functions in the real networks. And naturally more is better, but this is kind of what you need to deploy things. As a summary, well, we can see that this distributed architecture makes possible to deploy 10 gigabits to node level, and it can support also the legacy management system together with all the subscriber services. Everything is specified in Cable Lab standards. And it's not so big change to deploy that. Naturally, there are new things to learn, but it also enables many things to improve data services to subscribers. We have seen that there are some operators already started this work to study how they can do this distributed architecture deployments, but we would like to see more. So this is an open question how ready the operators really are to go this distributed architecture. Or what is the missing thing that prevent them to study this story? This time this was all from my side, so now I'm ready to answer a couple of questions.
Who's going to start with the questions? I think you've answered all of the questions there are to be answered by the look of it. So I will say thank you to you. Much appreciated. In our usual manner.